I'll start with three stories, and the first story is about a married couple who keeps looking for houses until they decide to buy one. So I want to suppose that after they see each house, they need to decide right away whether they want to stop and buy the house or they want to continue the search. If they choose to continue searching, then they cannot go back and get a house that they previously rejected. One possible explanation for that is the Canadian housing market is competitive and the house is gone before a new one becomes available. So in these situations, the main conflict is that the preference of the wife and the husband may not be the same. So throughout this presentation, I will use diagrams like this, where on the horizontal axis is agent 1's valuation, and on the vertical axis is the agent 2's valuation. And for example here, there are ratings between 1 and 10. And one example of a decision rule would be like this. They would buy the house if the sum of their ratings is above some thresholds. So here, the shaded region is where they stop and buy the house, and the remaining region is where they continue the search. The decision rule does not need to be symmetric, so if the wife is more important, then her rating may be weighted by 2, and similarly, if the husband is more important, then his rating may be weighted by 2. So the diagrams would look like this. And the extreme case would be the wife being a dictator or the husband being a dictator. Another very popular rule is that each member would rate the house by three possible things: ideal, acceptable, or uninhabitable. So they would buy a house if no one feels this house is uninhabitable and at least one person really loves this house. It's the ideal house, and for the other person it's at least acceptable. So it turns out that this class of mechanism is very important, so I would call them ternary rules, ternary because there are three possible votes. My second example is about a hiring committee who receives job applications and conducts interviews until a position is filled. So again, I want to assume that a decision needs to be made right after each interview. So one possible explanation is that they are small schools. So for large schools, this assumption does not hold, but for smaller schools where there are only few candidates, then this decision rule, this assumption may hold. And also, if you think about each interview as an interview of a group of people, then you could think about this problem as whether you hire one person among this group or you continue search and get another group. So that would be a possible explanation as well. So in these situations, unanimity rule is a very popular rule. And unanimity means each member of the committee, if each member of the committee likes this candidate, then the candidate is hired. So note that the decision boundary does not need to be straight lines. So for example, if a candidate has valuations 4.5 and 9, then that candidate should be hired, so that decision boundary can be curved as well, like the diagram on the right. My last story is about two co-authors that gain access to new data sets periodically. So one popular rule is what I call the reverse unanimity rule, where if any one of the co-author thinks this data set may lead to interesting results, then they will start working on this project. Again, the decision boundary does not need to be straight lines.